Welcome back 10th standard. The last video that I shared was on how to divide a line segment of the given length in the given ratio using the alternative method given in your textbook. I'm going to do the same question with the first method that's given in your textbook. The first thing we want to do is we want to start with the line segment of the given length. The length given to us in this question is 7.6 centimeters. So let's draw a line segment of length 7.6 centimeters. Naming the line segment as AB. Let's write down that the line segment that I have here with me, AB, is of the length 7.6 centimeters. This is first question from exercise 11.1. The next step will be to construct an acute angle at the vertex A. So I'm going to construct an angle of 30 degrees at A with the help of a pair of compasses. So I'm going to fix a radius and then draw a semicircle from the point where the semicircle meets the line segment. I'm going to draw an arc. This is an angle of 60 degrees. You can work with 60 degrees as well. I'm going to bisect it in order to obtain an angle of 30 degrees. Bisecting an angle of 60 degrees. This point of intersection of the arcs will give me an angle of 30 degrees right over here. Let's bring the ruler and draw a line segment to join the vertex with the point of intersection of these arcs. Putting the ruler away, let's name this arm as AX. Therefore, angle BAX is 30 degrees. I've constructed this with the help of ruler and compasses. Now I'm going to use the ratio given to me, which is 5:8. I want to divide the line segment AB in the ratio 5:8. This tells me that I need a total of 13 arcs along the arm of the angle I have constructed right now. So I'm going to cut off 13 arcs along AX. And all these arcs will be spaced equally, and I'm going to take the distance as 1 centimeters. Starting from A, I'm going to cut off 13 arcs spaced equally from each other. So let's use the ruler, open the compass 1 centimeters, and I'm going to fix the radius here. And then starting from point A, let's draw 13 arcs. This is 1, this is 2, be careful with the point, this is 3, this is 4, five, 6, 7, 8, 9, 10, 11, 12, and 13. I'm going to name these. Let the first one be A1, then the next one will be A2, A3, A4, A5, A6, so on up to A13. I'm going to join this 13th point with point B, the other end. This is the line segment I'm going to draw, joining B with the last point obtained along the arm, and that I'll do with the help of a ruler. So once you've joined this, I would like to draw a line parallel to this from the fifth point. So from A5, draw a line parallel to BA13. So that line would appear right here, which will be parallel to this line. For that, I'm going to use the concept of constructing corresponding angles equal. I'm going to copy the angle from here, the one at A13 at A5. So copy angle BA13A at A5. And for that I would like to make use of the compass. I'm going to place the compass here. The angle that I want to copy is on this side. So let me just change the radius, and I'm going to change the color also so that it's a little convenient. Okay. So drawing an arc from here and using the same radius, I'm going up to A5 now. Draw a semicircular arc at A5. This is the same radius with which I have drawn this arc at A13. Yeah. So the radius which I've used at A13 is the same radius with which I have drawn this semicircular arc at the point A5. Now what I want to do is I'm going to measure the length of this arc. So I'm going to use the point here and the beginning and the end points of this arc. I'm going to measure its size with the help of the compass. So I'm going to place this compass here, and I'm going to measure the endpoints. I would like to change the radius now. So opening the compass of this size, the length of the arc, I've opened the compass of this size, and I'm going to fix the radius. Using this radius, I'm going to come here on this side, and I'm going to cut off an arc along the semicircle here. And then this is the copied angle. So angle from A13 has been copied here. I would like to join point A5 with this intersection and produce it further to meet the line segment at a point. And for this I'm going to use my ruler, and you'll be able to see that the line segment actually is parallel here. So I'm going to just draw the line segment right through this point. This point is point P, and we have obtained two parallel lines. The ratio of AP with PB will be 5:8, and you can verify it by measuring the two parts. Let's use the ruler and see. The last time we measured the part AP was approximately 2.9. So this is what should be happening here. Let's take a quick look. So as you can see, it's approximately 2.9, and maybe I have not been precise while joining A5 with this angle over here, otherwise it would have been 2.9. So you can do it and obtain. Now the justification part. How do we justify that the ratio of these two parts is 5:8? And this can be done again by proving the smaller triangle similar to the larger triangle. And once you have proven that, you can prove that the ratio of the corresponding sides comes out to be 5:13, and from there you can conclude that the ratio of parts AP and PB is 5:8. The second way to justify this construction is with the help of basic proportionality theorem. You can justify the construction by basic proportionality theorem. Since we have constructed a line parallel to one side of the triangle, this line will divide the other two sides in equal ratio. The ratio of AB and AA13 will be same. So what I have done is the ratio of these two parts. This is 5 units and this is 8 units. The ratio of these two parts is 5:8. By BPT, the ratio of AP and PB will also be 5:8.